I'd like to start off with a little movie to illustrate what R is and why you might want to use it. So you might be familiar with Excel, which has tables with data or data sheets, and these consist of cells with numbers, and using formulas you can create new cells with new values that tell you something about your data. And you can also make graphs or plots of your data. And if you want to do a little bit more advanced stuff, you might use Prism or SPSS because A, it gives prettier graphs, and B, you can do a little bit more advanced statistics. So these programs are basically point and click, so you interact with the program by pointing at stuff and clicking on stuff with your mouse. Then on the other hand, R is fundamentally different. It's a bit similar to MATLAB and Python, which are all scripting languages. So these are text-based, which means that if you look at how you use R, so most people use RStudio to interact with R, and RStudio gives you a text editor where you write down commands. You write down a sequence of commands to perform the task that you want. So everything you do in R, you do by writing down text and then telling R to execute those commands. And with this you can basically do anything you want to. So to illustrate this a little bit, first a biological example. I've been working on the analysis of tomo sequencing data. And here are also some examples from an earlier paper from our lab on TomoSeq data. So basically in TomoSeq, you collect multiple samples that are located over a certain area of your sample of interest. So here we took 50 samples from mouse hearts, and what you then get is for each sample, for each gene, the expression value of that gene. So you have a huge list. So here is only a small part of a table that results from such a data set. So you have values for each of these 50 slices or samples, and for each of the genes that are detected, which can be 5,000, 10,000, whatever. And so with this data, you want to analyze this data. So you want to make quality plots. You might want to select out certain genes that appear to be to have artificial patterns, or you might want to throw out samples that have a certain signature that shows that it's a low quality sample. You might want to characterize each of the slices using, for example, correlations, maybe a T/E map, PCA. You might want to visualize the data. You might want to cluster the slices together with similar slices. You might want to look at patterns of gene expression and how these are associated to transcription factors, or maybe ligand or receptor interactions, etc., etc. So those are all relatively complicated tasks which cannot be easily performed in Excel, as you might imagine. And also R has much more plotting capabilities. So here are some example plots. So to summarize some important features of R. So in R it's easier to build a very large pipeline. Basically you can make it as long as you want. It has much more capabilities because there are many libraries which are basically pre-written scripts available for plotting, statistical tests, the techniques that I just mentioned, PCA, T/E, that help you characterize data, specialized biological script, etc., etc. And that's less relevant for this course maybe, with scripting languages you can really build algorithms. So a simple example of an algorithm would be to manually calculate the square root of a number, but an algorithm is basically a sequence of instructions to perform any task. And so you can do mathematical modeling, machine learning, image analysis, whatever with scripting languages. And that's also why scripting languages are broadly used. So for example, Google uses R to improve search results, do financial calculations. It's used in risk modeling in banks. Amazon uses it for product suggestion, the weather service uses it, etc., etc. And also some examples from Python, which is very similar to R. So YouTube is largely written in Python, Netflix suggestions are coming from Python, and 21% of Facebook is apparently written in Python. Yeah, so we won't be focusing on these type of advanced tasks, but we'll focus on tasks like this in this course, and I hope that at the end of the course you can do similar stuff as I mentioned for this example.